Welcome to this lesson on equilibrium. Equilibrium is just another way of saying balanced. In order to be balanced, two conditions have to be met. First is translational equilibrium, which means that the net force on the object has to be zero. Secondly, rotational equilibrium, which implies that the net torque on the object also has to be zero. Both of these have to be true to be in equilibrium. Let's take a look at a ladder resting against a wall. The dashed lines along the bottom indicate that there is friction along that surface between the objects in contact. As a person climbs the ladder, the forces along the object change. If equilibrium is not maintained, the ladder and the person will fall. Let's compare the system now with the system before the fall. There has been a translation, which we see by following the center of mass of the ladder, and there has also been a rotation. If the ladder is to maintain equilibrium, the two conditions need to be met. Translational equilibrium requires that the forces to be balanced. So let's take a look at the forces on the ladder. The first one is the weight of the ladder acting at its center of mass. The second force is the weight of the person acting on the ladder as he's pushed down as the person climbs. There are two normal forces because the ladder is touching two surfaces, one on the ground and a second from the wall. And finally, for the ladder not to slip, there has to be static friction holding it in place. For translational equilibrium, the net force has to be zero. Looking at this in the x direction yields the forces horizontally as being static friction to the right and normal force 2 to the left. In the y direction, upwards, we have normal force 1 and the weight of the ladder and the weight of the person directed downward. Next, let's take a look at rotational equilibrium. For rotational equilibrium, the condition that must be met is that the net torque be zero. In order to establish torque, we need to know the axis of rotation or pivot. Objects naturally rotate about their center of mass. But since the object is in equilibrium, we can put the pivot anywhere we want. Let's pick a point that makes this a bit easier. By choosing this point, no torque will be produced by either static friction or normal 1. This is not to say that the forces are zero, only that the torque produced is zero because they both have no lever arm. Torque, by its definition, is r cross f, meaning the two vectors need to be perpendicular to one another. In magnitude, this simplifies to rf sine theta, where theta is the angle between the lever arm and the force. To establish the angles between the lever arm and the force, we need to look at a triangle at the base of the ladder. If the ladder is leaning against the wall at some angle theta, then the angle made with the vertical is phi. Now, let's take a look at the angle between each force and the ladder. Finding the portion of the force that is perpendicular to the ladder will look like this. Going back to our equation for torque, Again, to be in rotational equilibrium, the net torque on the object must be 0. Looking at the object horizontally for reference can help us with applying our signs for the direction of the net torque. The pivot is always set as the origin of our coordinate system. Our first force is at a lever arm R towards the center of mass times the force of the ladder sine of phi. So when I sum this to the torque, I have a positive lever arm and a negative force, which produces a negative torque and should produce a clockwise rotation. Our second force is out to the person, the portion of their force that is perpendicular, again, will produce a negative torque. And finally, the torque produced by the normal force 2 should be positive, as both the lever arm and the force perpendicular are in the positive directions. Looking at this all together, our three main equations that will define this system are the net force in the x direction, the net force in the y direction, and the net torque on the object. Algebraically, combining and manipulating these equations is what will be used to solve for different values based on given information in any situation.